right, in this lesson, we are going to breeze through a periodic table of the elements PowerPoint and just kind of nail down some just kind of simple observations. I'm going to read through this PowerPoint. I'm not in class, or I would be able to go on some sort of diatribe or some sort of different direction. But in this case, in this lesson, I'm just going to read through. And what you will discover is that we will go through some history of the periodic table. We will go through some classifications of the periodic table, specifically groups and families. We'll go through periods and groups to notice what they tell us about the periodic table. We will learn about how similarities of chemical properties and properties are very, very important. And hopefully by the end of this lesson that you'll have a more kind of standard way to look at this periodic table. I am in my house, so you might hear noise after that. So, first question, what is missing from this picture? What is missing from this picture, specifically the elemental blocks? Notice what's missing. Take your time. And I'm sure you picked it up already. What's missing is the atomic mass, or the average atomic mass unit. Again, remember that this number is based on an average of the multiple isotopes that exist in nature. That is why this number is not a simple 9, because there's multiple isotopes of each element on the periodic table. Now, when we think about the periodic table, we run into elements such as chlorine, silver, gold, oxygen, helium, neodymium, sodium, carbon, niobium, hydrogen. We see these elements, and each of them are placed on the periodic table for a specific reason, the similarities of their properties. Now, we've come a long way since Aristotle's theory of earth, wind, fire, air. And scientists have identified 90 naturally occurring elements. This is not super important, but it is good information to know. Scientists have identified 90 occurring elements in nature and created about 28 others. So we see the process of science building upon previous knowledge. The periodic table organizes the elements in a particular way. A great deal of information about an element can be gathered from its position on the periodic table. Now, this is very, very important to understand, that a great deal of information can be derived about an element from its position on the periodic table. You can predict reasonably good accuracy physical, right? Physical and chemical properties. When we're talking about physical properties, we're talking about things like soft, hard, brittle, dull, as far as luster is concerned. When we're talking about chemical properties, we're talking about boiling points, melting points, right? So these are the things that can be discovered based on a element's, or can be reasonably deduced based on an element's position on the periodic table, where it is placed on the periodic table. So let's learn a little bit of history really quickly. This is not extremely important. I'm going to let you yourself kind of go through this. But the big thing that I want you to take away is that Dobereiner discovered what is, or postulated what is called the law of triads. And what he said is that these elements in between specific elements, so you had up here between strontium fell between calcium and barium. If you look back up here, we can see that we have strontium between calcium and barium. And he said, Dobereiner said that there was similar chemical properties between strontium, calcium, and barium. In 1829, he discovered the halogen triad, chlorine, bromine, and iodine, and the alkali metal triad of lithium, sodium, and potassium. And again, he noticed that there were similar properties and that the middle element had properties that were an average of the other two members when ordered by the atomic weight. So this is the law of triads. I'd spend some time with that. Now we move on to John Newlands. He was into music, as you will be able to tell, music, and he came up with the law of octaves. And what he said is that elements would basically repeat similarities every 8. Remember, octaves, oct equals 8. And so he published his version of the periodic table and proposed the law of octaves. So by analogy, with the 7 intervals of the musical scale, this law stated that any given element would exhibit similar behaviors to the 8th element following it in the table. Pretty simple, the law of octaves. So he said that every 8 would exhibit specific properties, similar properties. Okay, now we're getting into who we really know, Dmitri. So he published his first periodic table in 1869. That's pretty important to know about Mendeleev. He grouped elements according to their atomic mass. He found that there were properties in families, and he's given credit for the first modern periodic table because he was smart enough to leave blank spaces to predict certain elements that were yet to be discovered. These elements were soon discovered, and it legitimized Mendeleev's postulate about based on atomic mass. So this is a picture right here of it's not Mendeleev's actual periodic table, but it's kind of what he was proposing. If you'll notice, because he arranged that periodic table in with mass instead of atomic number, some of those elements are out of order. And if you looked at it based on his periodic table compared to our periodic table, you would be able to recognize that some of them are out of order. Okay? Again, notice that his periodic table is based on the similarity of properties and reactivities exhibited by certain elements. So there are certain similarities of properties and reactivities and physical and chemical properties based on certain elements and where they are placed on the periodic table. So then we have Moseley. Moseley arranged it based on the number of protons, otherwise known as the atomic number. Realized that the number of protons that gave the atom its identity. Now, he figured out this number of protons, figured out the number of protons in every element with an X-ray analysis. And that's what this is over here. So what he did was he bombarded specific metals, right? Specific metals with electrons. Now, how did he do that? He hooked a source up of electricity and sent those electrons in. Boom, electric electrons, sent those electrons in, and then he took an X-ray. He could count out the number of protons in each element. So what he did was he reorganized Mendeleev's periodic table by atomic number and fixed many of the issues with it. So then you get to Seaborg. Seaborg's an interesting fellow because he took out the lanthanides and the actinides from the periodic table itself, and he created a separate block of elements. These elements have their last electron placed into the F sublabel. Let's just remember that. This is the S, this is the P, this is the D block, and this is the F block. So this allowed the elements that had their last electron placed into the sublevel D to stay in order. So it allowed the electrons to stay in order when he took these out. Okay, and it also made the periodic table able to fit on a single sheet of paper. So thank you, Seaborg. Now, The periodic table can generally the periodic table can generally be split into three different categories: non-metals, metals. Now notice hydrogen is over here, non-metal, but it does only have one valence electron, so it fits into group one. And helium is over here and has two valence electrons, and it fills its outer shell, so it exhibits properties of noble gases. But anyway, nonmetals, metals, and metalloids. Okay? And then you have your lanthanides and your actinides down here. So, we'll come back to this. I just want you to kind of review that, take some notes on that, and we'll go over some different properties in just a moment.